to everybody from wherever you are in the world. My name is Catharine Terwischa van Scheltinga. I'm from Wageningen University and Research, and I'm your host for tonight. My colleague Judith Snetlager, who was going to be the host of this session, is still in the field, so she will be hopefully joining later, but it might be that she cannot come tonight. However, this is an important topic, and we are very glad that in this Gobeshona conference, we can discuss together about water management, agriculture, and salinity, and then in particularly the case of coastal Bangladesh. We look at local level adaptations, what kind of knowledge is there, what kind of activities are there, what is not yet there, and what are we looking for to get action and to further local level adaptation. From the side of the organizer, ICAT, Madiha, are there any issues from your side that you would like to discuss?
No, it's fine. You can go ahead, ma'am. You can go ahead.
Okay, thank you so much. We are very happy that ICAT is facilitating this session for us. The session will be registered and will be later on available so that you can also see it back. We know that some of the people are not with a good connection. Do not worry, you can still see the session later on as it is registered. I will provide you with, I need to see how I go to the next slide now. Yes, I'm now giving you a brief introduction. We will have 3 presentations today, all related to the salinity issue in southern coastal Bangladesh. And we will conclude with a panel discussion. We hope to finish by, and I now should say it all right, 9, 10 or 10:30. We will try to be as concise as possible, not to take you too much of your time, but please feel free.
Shamsa, is there any way you could reach her to just have an update?
So, I don't know. So I think Catherine just dropped out. I don't know.
I just called her. She has a problem with her mobile data. She's trying to reconnect.
Okay, all right.
But she suggested that we will start with the presentation of Isfat. So I would like to introduce Isfat, who is a PhD student at Wageningen University and Patuakhali Science and Technology University. And he's at the moment a PhD student with us within the Climate Smart Agricultural Project. And he will show his results of his field survey on soil and water salinity. Isfat, the floor is yours.
Yeah, thank you, Fulko. Can I share my screen?
Yes, go ahead. Go and share your screen and your presentation. Yeah. We can see your PowerPoint now, Isfat, but it's not in presentation mode yet.
Okay, can you see my PowerPoint?
Yeah, we see your...
Yeah? Is it visible, Fulko?
It is visible, but not in presentation mode. And we see maybe just a...
Open your presentation and then share, go to share screen.
Yeah.
Yeah, I just share my screenshot, but I don't know what could be happened here.
Okay, now we see your PowerPoint.
Yeah. So just then go click on the full screen. Yes.
Yes. Now it's visible?
Yes. Go ahead.
Okay. Okay, thank you. Thanks for giving me an opportunity to presentation. This is my PhD research and my past PhD research. It will be the first chapter of my thesis. So my title is the spatial temporal variability of soil and water salinity in the southern central coast of Bangladesh, a multifactorial analysis. And here I'm Isfat Bhuya. I'm the PhD student of Wageningen University, and Fulko Ludwig is my promoter, and Ivan Supit and Shamim Mia is my Professor Shamim Mia is my daily supervisor. Let's see the background. Salinity, the salinity is one of the most most vital issue in the coastal region of the Bangladesh. And salinity is considered to be one of the major challenges. This is methodology. Our research is a southern coastal area. So we are dividing our 4 districts. We are covering the 4 districts and 12 upajelas. And it's the Borishal, Jalokati, Pargona, and Patuakhali districts is our study area. And we are collecting the soil samples from the study area, from soil and water sample for the month of November 2020 to June 2021. We are collecting the soil sample from both inside and outside the polder. At the same time, we are collecting the soil sample for all the rivers in the southern coastal belt of Bangladesh. And most of the time, the soil salinity near the coast is very high, but it varies from east to west and north to south from the coast. So that's why we are collecting the soil sample from the south to the north, and the similar grouping was applied from the east to west of the southern coastal belt of Bangladesh. And we are also collecting the special soil sample from in April 2021. We're expecting the salinity will be higher on the time, because in different literature we have seen that the salinity is very high in the month of April, but this year we have found the salinity is very high. So we are discussing in the result section as well, because the rainfall and there's not too much rainfall on the time this year. And we are also collecting the satellite image data from USGS, and we know that we are not collecting the soil sample for the whole region is not possible. So that's why we are collecting some satellite image data to compare our results with this data. And the result section, this is the special salinity variation in the month of April. We have seen that there is we have collected soil sample from the medium land, medium highland, and the highland. And we have seen that in the right corner of the results, we have the medium land, the salinity is very high, and the highland is the salinity is very lower. The medium land salinity is most of the cases is very high, than more than 8 decisiemens per meter. So this is very high in the medium land. At the same time, we have seen that the same type of land, the salinity also variation of salinity also there. In the same land, there is a lot of salinity variation. Because in some areas there are some polder up there, so that's why they protect the land to saltwater intrusion in the some areas. So that's why the same land have the different salinity variation. Salinity also variation in the land use type. We have seen that the fallow land salinity is very higher than the cropland. The fallow land salinity is very high in this case, because this land is really remain fallow. At the same time, due to capillary raise action, so salinity goes up to the soil. That's why the fallow land salinity is very, very higher than the cropland. And the next slide, we have divided the 3 zones. The high salinity zone, medium salinity zone, and the low salinity zone. And this is the main part, the main basic of my PhD. We are doing the crop modeling in our second and third experiment, and finally we are give some crop level adaptation options in those regions. So this is the main basic thing of my research. So the high salinity zone, the salinity is very high. In these cases, that the salinity, most of the cases, salinity is 4 decisiemens per meter for the lower cases, and the 25% of the land in the upper quartile, the salinity is 9 decisiemens per meter, and the average salinity of the high salinity zone was 9 decisiemens per meter. So this is the very high salinity. So in the high salinity zone, so this is most of the crops are not growing in the region, because the crop tolerant limit is very most of the crop tolerant limit is not too much. Threshold limit is crop threshold limits cross the crop threshold limits of most of the crops. And medium highlands, the salinity level is a little bit lower than the high salinity zones. And these salinity zones, we have seen that most of the average salinity is 4 decisiemens per meter. So some salt tolerant crops can grow here. And the low salinity zone, the salinity is not too much high. The average salinity is 2.5. So this is for the main reason, but the low salinity zone, because a lot of fresh water flow. That's why in the Borishal, Jalokati, in the low salinity zones, so there is not too much salinity as well. And whenever we compare our result with the satellite image data, we have seen that the NDSI value is very high near the water bodies, and the lower in the most northern part from the coast. It's the Borishal regions. The salinity is not too much higher because of freshwater flow. And the high salinity zones is near the water bodies. We have seen that Kolapara, Antoli, and some Potokali regions, the salinity is near the water bodies is very high. Whenever we compare our results, NDSI value with our data, then we have seen that there is highly significant, and the R square value is 7.8. So we have seen that the salinity also increasing with distance from the sea in these regions. And we have seen that we have also plotted our results with EC value with distance from the sea. We have seen that we have monthly salinity plotted against distance from the sea. We have seen that soil salinity is very high near the coastal areas, and the soil salinity decreasing with increasing the distance from the sea. Similarly, we have already seen in our river water salinity also decreasing with increasing the distance from the coast as well. And we have seen that we have seen in the figure that the salinity is very high in the month of May, but we are expecting the salinity is very high in April. That's why we have already been collected data in the special soil sample data in different southern coastal belt in the month of April. But due to this year, the rainfall is very low in the month of May. At the same time, there is a high temperature, so salinity is very high due to evapotranspiration. So a lot of salinity is due to capillary action raising in the soil. So that's the main reason for that. The salinity is very high in the May, and the salinity is very low in the month of November. But salinity both of the cases for the river and soil salinity, the salinity begins from the month of November and is high in the month of May as well. And it was declining in the month of June due to increasing due to rainfall in the southern coastal areas of Bangladesh. And we also do that. So variation of salinity, we analyze the variation of salinity inside and outside of the polder, and we have seen that there are some figure in the left corner of the slide. We have seen that inside of the polder salinity is very lower than the outside of the polder. So this is the average EC value for the 8 months. This is not for the 1 month, so it's for the average salinity value for the 8 months, EC value for the 8 months of the southern coastal areas. We have seen that the error bar is very higher. Error bar is very high for the outside polder, so there's a lot of salinity variation than inside of the polder of the southern coastal areas. And then finally, we are comparing our result with the comparing historical comparison of our measured data with some historical data of SRDI. 1973, we have seen that there is a slightly salinity areas and there is a moderate salinity areas. There is no salinity areas in Jhalakati and Borisal districts in 1973. But in 2021, we have seen that some areas of Jhalakati and Borisal regions, there is some high salinity areas we have seen, but it's a little bit of, there's not too much, but we have seen that some highly and moderate salinity areas is seen in the Jhalakati and Borisal regions. We know that these regions have a lot of freshwater flow and salinity is very low. So there, that time we have seen that this is for the masses. What could be the salinity in the next 20 years? What could be happen? So it's not a good situation right now at this moment. And in case of Patuakhali and Barguna district, we have seen that the high salinity and severe salinity areas is very high in 2021. And when the day progresses, then the salinity and slightly salinity and moderate salinity area decreasing, and highly and severe salinity increasing in case of Patuakhali and Borisal regions. There's some pictorial view of my data collection, and we have collected some data. In the left corner, Professor Shamin sir also with me for data collection, and the middle figure, we have observed some white crust of the soil whenever I collect data. And this is for the first time I have seen that. I have read some literature, I have read some books, white crust of soil, due to salinity, for the salinity. So this is for the first time I have seen that white crust of the Simon sir also shown to me that is a white crust of soil is formed due to salinity condition. And this is for some picture of the pictorial view, and we have seen that some rice field also affected by the salinity. And the standing crops, this is not good. There's a lot of standing crops are affected by the saline soil. So this is very terrible at this moment. And you know that there's a special salinity variation the same land, there is a lot of special salinity variation are there. Some part of the lands are crops are grown, but some part of the land there is no crops are grown. So this is part of the situation right now in the southern coastal areas of Bangladesh. And this is also some pictorial view of the middle part. I have collected some water sample data from the rivers. This is maybe the Kolapara, this Kolapara regions, and it is maybe the Andermanik River. And the last figure for the right corner, Professor Shamim sir also observed my data collection. He's always with me for most of the time whenever I collect data, and he's very good scientist as well, and he's helping me a lot during the data collection time as well as the analysis of data. And take home message: the salinity is the most dominant limiting factor in the southern coastal areas, especially during the dry periods. And the soil and water salinity, we have seen that varies with the distance from the sea. And near the shoreline, the salinity is very high, and it will above many crops threshold level. So the crop cultivation is very difficult in these regions. At the same time, we have seen some special salinity variation in the southern coastal belt is observed. And also we have seen that the salinity also varies different land types and land uses as well. And we have seen that salinity and the polder and outside of the polder, the salinity is very higher than inside of the polder. And the polder protects the land from the direct saline water intrusion, but and at the same time, so we have seen that the soil salinity also very high. The moderate and high and severe salinity area increasing day by day, and especially in the Potokali and Borgona districts. So my final message is to proper salinity management will be required in the southern coastal part of Bangladesh to ensure the food security. And that's all of my research presentation. Thanks to all for patient hearing. And you can ask me any questions. Do you have a question? You can ask me.
Thank you very much. Thank you very much, Isfatuzzaman. Sorry, I am on a very kind of unstable connection. That's why I lost the connection. And thank you very much, Professor Fulco, for stepping in and continuing. If anybody has some question for Isfatuzzaman, please put your question in the chat so that we may ask it to him. And while you are doing that, maybe I can ask Isfatuzzaman a question. Isfat, you are collecting data at a local level,
yeah.
And you compared it with the data of SRDI,
yeah.
and you are seeing that there is more salinity.
Yeah.
Is this salinity kind of throughout the year, or is this salinity different in different times of the year? Can you say something about that?
Yeah, that's a very good question. I'd say because we are collecting salinity only for the dry period, not throughout the year. We're only collecting salinity only for the dry period. From November to June, I have already been mentioned in my methodology section. So yeah, we are collecting only for the dry period. We are comparing the
okay. So when you
salinity, yeah, not for the whole year. Yes, good question, because I have a plan to collect the soil sample for the whole year because my PhD is very time limitation, you know, but it is not possible to collect the whole year. The salinity collection is not possible in some cases. But yes, in future I'll do that. It's very good question. In future I'll do that. Yeah, it will be very important. Yeah.
Okay.
Maybe some questions.
There is a question in the chat. Yeah.
What are the? Yeah, it's very good questions, Dr. Joyanto. So this is a very nice question, and yeah, yes, my PhD, my second and third experiment, we are doing crop modeling with the different salinity levels. Then we will follow. We will do some crop level adaptation and some management options. I will not work for the whole. But my message is to the stakeholder: what is the present situation of salinity in the southern coastal belt of Bangladesh? So yeah, that's very good. So in future I'll try to do that. So some management issue. So we'll not recommend some management issue without any experiment.
And Dr. Jointo, please, if you wish, we can also communicate to you. Put an email address in the chat, and then we'll link you up with Isfatuzzaman. Thank you very much, Isfatuzzaman, for this presentation. We now move on to our second presentation, and that is by Mehdi Hassan Mitu. Is he already in the?
Maybe Catherine, I have another question.
Is Mehdi already in?
Catherine, maybe
I know I
someone
saw the
asked me
question, and please.
It's very good question. Sort of man-made
Okay.
reason. Yes, it's very good question for that. As anthropogenic man-made is a different issue. So people are using most of the times that land remain fallow. So fallow land is also responsible for I think increasing soil salinity as well. This is also sometimes the people are using this saline water for irrigation. It is also for the anthropogenic factor for salinity increasing. And I also think that there is an cropping strategies. Farmers are not cultivating crops for the whole year, and that's the main thing is that fallow land is the mainly responsible for the salinity, increasing salinity in the coastal belt, because there's a lack of salt-tolerant varieties up there. The salinity, I have seen that the salinity is very high. It's more, especially the high salinity zone. The salinity is more than the average salinity is more than 9 decibels per meter. So, yeah, the crop are not cultivated in the season, so salinity is very high. So my suggestion is that to introduce some more suitable varieties, suitable salt-tolerant varieties, also some suitable water harvesting technologies and some other technologies we have to be prescribed to the farmer in future.
Okay, thank you very much. In light of time, I'm giving the floor to the next presenter, Professor Shamim. You already shared your screen. Please go ahead.
Thank you. Our student, Mr. Mehdi Hassan, cannot join from his computer due to unstable connection. So he will be presenting from my laptop.
Thank you. This is Mehdi Hassan, MSc student, Potokali Science and Technology University. Today I'm talking about how to biochar compost play a role in saline condition at Mung production. Biochar is a term of pyrogenic carbon. It is produced by heating biomass under limited oxygen condition. In this process, about half of original carbon is retained, while the form of carbon is changed from aliphatic to aromatic carbon. In contrast, burning of biomass may be lost most of its carbon remaining living minerals there. That is called ash. If you look at this picture, you can see that porous surface area. It's a close image of biochar. In this surface area have many functional groups like phenolic, carboxylic, etc. When biochar is going to activation process, functional group are increased, and this functional group can be whole soil nutrient for further nutrient supplement. If you look at the picture, soil crust is spread in this field. This is one of the most challenging issues in recent years. Application of biochar can be mitigation tool of this salinity. Let's have a look. Biochar have numerous microspores that can hold soil water. This soil water have the potentiality to dilute salt, which have rich in saline soil. In this process, salinity can be suppressed by biochar. Biochar surface properties also reduce salinity by increasing sodium buffering capacity. So keeping all of this in mind, we set a novel objective. These are to examine the salt buffering capacity of different soil types. And the second one was to investigate the effect of biochar compost on the performance of Mung bean when applied at increasing rate. And the last one was to look into the residual effect of biochar compost on the performance of Mung bean. So for achieving this goal, I conducted 3 studies. There are experiment 1, determination of sodium buffering capacity of different soil types, and the experiment 2 was effect of different biochar compost application rate on the performance of Mung bean yield at different salinity stresses. And the last one was residual effect of biochar compost on the performance of Mung bean under different salinity species. Firstly, I conducted an incubation study where the incremental amount of salt up to 6 was at to 100 gram soil. Here I was three different soils. Here I was used three different soil, clay, silt, and loam. We examined the water loss and different date and soil electrical conductivity at the end of incubation. We also observed the relationship between salt addition and soil electrical conductivity. As we see here, soil electrical conductivity of clay soil was positively associated with saline condition, where the loam and seed loop followed a non-linear relationship. Moreover, salt buffering capacity of clay soil was much higher than other soil, which was plausible since clay soil carries large surface area and charges. These findings suggested that soil salinity may be much lower in clay type soil than light soil, although they receive similar salt loading. And the other implication of this study is that amount of salt required for getting desired soil electrical conductivity can be obtained through a application of this equation. Now I will talk about my second study. In this second study, we had two factors. Factor A, different level of salinity from 0 to 12 decisiemens per meter. And second factor was biochar application rate at increasing level from 1% to 3%. In this experiment was conducted in small pots, small plastic pots, which contained 200 gram soil. We raised Mung bean in this plastic pot, and we recorded water loss and biomass production and soil properties data. Let's look at the results. We have several variables to present, but due to time limitation, I will not show all of results. I will focus on the biomass production. If you look at this figure, biomass production is significantly affected by soil interaction between soil amendment and salinity. Salinity significantly reduces the biomass production, while the biochar compost increase it with the largest increment of 3% application of biochar. These findings indicate that increasing rate of biochar compost can be increasing the buffering capacity of soil in saline condition, and this interaction gives an opportunity to increase biomass production. In my third study is about investigation of residual effect of biochar compost on performance of Mung bean at different salt stresses. In that study, we had again two factors. First factor was soil amendments like control, cow urine compost with cow urine, biochar compost, and biochar compost with cow urine. And the second one was 3 decisiemens per meter, 3 decisiemens and 6 decisiemens per meter salinity condition with control. This organic amendments was applied and then ammonia rice. And then I started my experiment after harvesting of ammonia rice. After harvesting of rice, we cultivated Mung bean and we imposed salinity by encircling Mung bean plant at age of 15 days. And we collected following data like plant attributing characters, soil properties, and plant nutrition concentration. Again, there are so many data to present here, but I would like to focus on seed per plant. If you like to look at the grain yield of Mung bean, these soil amendments and salinity both are performed significantly in Mung bean yield. And we found a promising result that biochar compost significantly increased seed yield of Mung bean irrespective of salinity treatment. We performed a principal component analysis. As you know, that principal component analysis is used to understanding interrelationship between variable and also show the link between variable and treatment. For example, seed yield is positively associated with plant phosphorus, seed per plant potassium, and negatively correlated with sodium and soil electrical conductivity. In our study, we observed a significant improvement of plant performance in terms of biomass production and seed yield. We believe that this was manifested due to an improvement in plant available water and increasing acquisition of nitrogen, acquisition of nutrient, including nitrogen. This increased nitrogen acquisition was occurred by an increased biological nitrogen fixation and nitrogen uptake from soil. Moreover, an important of plant phosphorus and potassium uptake contributed to perform a better yield. So all of these results, we concluded that clay soil has the highest highest salt buffering capacity, and the second one was an application of 3% biochar compost significantly increased production of mung bean, and the last one, residual effect of biochar compost application can elevate the salt performance of mung bean with a greater seed yield. Thank you.
Thank you very much, Mehdi. Any questions for Mehdi? Can you please put them in the chat? Fulco, you have raised your hand. Please ask your question.
Yeah, thanks, Shamin. Very interesting presentation. So what I saw overall is that a biochar, increases production, and it's basic. But you also see that if you add the salinity, that it basically reduces production throughout the different kind of treatments. So what is the real interaction between the biochar and the salinity? Because I saw that it's basically going down in all your treatments. I didn't really see a much more positive effect of biochar at higher salinity.
Sorry, I cannot hear your question. Please repeat it.
Okay, sorry, I'll repeat again. So if you look at especially the biomass figure at where you added the biochar at different salinity levels, yeah? So you see in the control, biochar really increases the kind of production.
Yes.
But if you add the salinity, it still basically increases the production, but I didn't really see the interaction between salinity and production. So can you tell a little bit more about that?
In this experiment, we used three types of biochar rate, like 1%, 2%, and 3%. We can show that the 3% biochar compost performance was better than 1 and 2% biochar compost.
Yeah.
When we used maximum, we used higher rate of biochar compost. When we imposed salinity in our pots, and saline are, we know that the biochar compost holds more water than soil, so it's helped to remit the salinity in saline soil. So it's a great opportunity to plant to performance the greater yield.
Okay, thank you.
Thank you very much. There's also a question of Dr. Jointo Bhattacharya in the chat. Can biochar change the organic matter percentage? Is there any effect of organic matter on biomass production or yield of mung bean? Do you have any information on that, Mehdi? I'm not sure if you got the question.
Yes.
The question is in the chat. Dr. Bhattacharya asked, can biochar change the organic matter percentage? Is there any effect of organic matter on biomass production or yield of mung bean?
Oh, thank you. It's a good question. We have not enough data for this question, but we have a sample showing this result. So further experiment, we can say that our
Am I getting you right that you're saying that in further research you will try to address this question based on the data collection that you have already done? If there are at this moment with the third presenter, Professor Shamim, is Professor Kamal there, or is his presentation there?
I think, yeah. He lost his brother-in-law and he is not here, but one of his students will be presenting in favor of him.
Okay, please.
He's with me, so just yeah, I can.
Yes, if you can please put.
I'll share the slides for him.
Thank you so much, and please convey our condolences to Professor Kamal for his loss. And the name of the presenter is?
Okay. You introduce yourself first and then go ahead.
Hi everyone, this is Mohammad Rukunujaman, MS student, Department of Soil Science, Potwakali Science and Technology University. Today, I am talking about management of saline soil using organic and inorganic fertilizer for maize production in coastal saline region of Bangladesh. First, I would like to talk about the research background. Saline soil is a major concern to agriculture all over the world because it affects almost all plant functions. In the southern part of Bangladesh, also affected by soil salinity, and this is increasing at an alarming rate due to the rise in the sea level, and many new areas are affected by saline soil, which causing a low yield of maize. And this situation can be improved by using organic and inorganic amendments. Now I would like to talk about the objectives. The main objectives of this research is to evaluate the organic and inorganic amendment on reducing soil salinity and increase yield of maize, and also to study the properties of soil saline area. To achieve the objectives, we conducted an experiment in Rampal, Bagirhat. Here, there two factors are used, fertilizer and saline water irrigation. There are 8 treatments are conducted. Among them, first 4 is first 4 at 3 decimen per meter saline condition, and last 4 at 6 decimen per meter saline soil condition. Here also used biochar and cow dung. Here we collected these parameters for statistical analysis. And now I am showing some results of this experiment. In case of the effect of organic manure and inorganic fertilizer on maize, here we have several variables to present, but due to time limitation, I will focus on yield of maize. Here we can see that the highest yield of maize is found in T3 and T4 at 3 decibel per meter soil condition, saline condition. We also found better yield in T7 and T8, where the saline condition was 6 decibel per meter. From this result, we can say that in saline condition, Biochar and cow dung had more opportunity for better yield of maize. In case of effect of organic manure and inorganic fertilizer on soil electrical conductivity, here we can see that the lowest electrical conductivity was found in T3 treatment and T4. In T3 treatment, we used 100% in NPKs with cow dung at 3 decibels per meter saline condition. In case of 6 decibels per meter saline condition, T8 and T7 also perform better, where T8 treatment is conducted with 100% NPKs and biochar. Now I am showing the effects of organic and manure and inorganic fertilizer on nitrogen percent on sodium chloride percent in saline in soil. Here we can see that in 120 days the sodium percentage is lowest in T3 and T4, where in T3 cow dung was used and T4 biochar was used. We also see that in case of T7 and T8, also lower sodium chloride percentage than other treatments. Here we can see changes in soil properties as influenced by integrated use of manure and fertilizer treatments on soil. Here we have parameters of total nitrogen, available phosphorus, extensible potassium, and available sulfur. Here I will focus on available phosphorus. In case of phosphorus, we can see that here also T3 and T4 are perform better in 3 decibels per meter saline condition. In case of 6 decibels per meter soil condition, T7 and T4 also perform better. Above this statistical data, we can say that the application of cow dung with 100% NPK showed significantly higher crop productivity in maize and reduced soil salinity compared to biochar and 100% NPK's application. We can also say that Biochar application increase nutrient status of soil. Thank you for this.
Thank you for your presentation, and thank you for stepping in and giving the presentation on behalf of Professor Kamal. Thank you for that. Any questions? I think it's a very interesting way how you are kind of looking at details and collecting facts on what works and what doesn't work. I have a question with regard to that. In your experiments, do you also link to farmers in your experiment? Have you shown to farmers what you are doing?
At this point, we do not contact with the farmers. Yeah.
Are you considering to do that in future?
Yes, we are concerned. We'll consider this.
Okay, very interesting. I didn't get any question in the chat, so I think we can proceed. Thank you very much again for your nice presentation. Please do share with us also the presentation so that we can after the meeting.
I have
Yes,
one queries, but here you see that cow dung with NPK reduce salinity. But what is is there any mechanism how cow dung, if a cow dung can play a role to increase reduce salinity, but biochar also application here. So biochar and cow dung also application here. So my question is how cow dung play a role to reduce? Could you describe how cow dung? Is there any analysis that in your analysis shows you have done that cow dung reduce the soil salinity? But how did you do that? That's my question.
This question will answer by Professor Shami.
Well, thank you for your question, Isbat. Professor Kamal is not here. I think it's probably difficult for the student to answer this question. So for me, I think, when you apply organic amendment, then the organic amendment can buffer soil salinity a bit. At the same time, if you apply nutrient-rich organic amendment, for example, cow dung in this case, can increase nutrition, can increase nutrient availability, and then can promote crop growth. I believe that could be one of the potential mechanisms. So I don't know whether they examine this. So I guess that these are the reasons. Thank you.
Yes, sir. So I agree with you. The cow dung application increases promote the growth of crops. That's good, and that also reduce the soil salinity. But yeah. Thank you, sir. Yeah, I understand. Sir. Yeah.
Okay, but this is a good and valid question. And in the earlier session, Volko asked a similar question, and then I refer to the remark that was made that biochar increases the sodium buffering capacity in the soil. So both biochar plus organic matter, cow dung in this regard, then both the nutrition status in the soil goes up, plus the buffering capacity to catch the part of the salinity which is non-conducive for plant growth. But this remains a good question, and in a way, which one to do more, etc. You can have a lot of research on that as well. Again, it comes back to the point also what is for farmers possible to do and what is kind of feasible to do. But I think it's a matter of working from two sides, and then we are trying to collect facts in this way. That's how I understand it, because in order to advise farmers, you also need to know what is going on. So that's what you're working on. Thank you very much for sharing that. I saw a hand of Professor Fulco, but I saw it disappearing again. So I think he will wait for his time in the panel to say the next thing.
Yeah, let's do this later. It's fine. Yeah, continue.
Yeah. Okay. Thank you so much. Thank you once again. Thank you also, Shamim, for organizing that everything runs smoothly despite of the internet connection. Thank you also for the audience for all your patient hearing so far. If you want to say something or if you want to ask something, please feel free to put it in the chat. I'm now moving on to the panel part. We had invited Dr. Kadir, but Dr. Kadir is at the moment at Biochar, so he could not join us today. But Professor Fulco Ludwig is with us, and so I'm asking him to introduce himself before reflecting on what we want to address in the panel discussion, and that is the question: what is kind of at the moment ongoing in research? What are then the knowledge gaps, and what are then the kind of actions that we need to tackle it? And beside Professor Fulco Ludwig, also Professor Shamim from PSTU will join the chat. So I first give the word to Professor Fulco Ludwig to introduce himself briefly and to say something about the topic. And then the word will go to Professor Shamim, who then will introduce himself and say something about the topic. Professor Fulco, the floor is yours.
Okay. Thanks a lot, Catherine, and thanks to all the speakers for a very interesting talk. So my name is Fulco Ludwig. I'm a professor at Wageningen University on water and climate change, and maybe my Bangladesh. I've been working in Bangladesh now for about 10 years. And the two issues where we focus on in Bangladesh is the impacts of salt intrusion and climate services. So we've been looking at that salt intrusion in Bangladesh for over the last 10 years. So I find it's a very interesting session. And I was also looking at the three presentations here today is how can we combine those a little bit? And what I've seen with the experiments in Bangladesh, when we look at salinity impacts, what we do in terms of good experiment is that we give the same salinity treatment throughout the growing season. But if we look at ISFAT's work, and probably everybody living in Bangladesh knows that actually the salt intrusion is often increasing over the dry season or could be changing over the growing season. So I think there's a bit of a need to adapt our experiments a little bit to what happens actually in the natural cycle. And maybe we should also, in terms maybe of field experiments, or we could even do it in pot experiments where we represent a little bit more what is happening in nature to really look at how plants are responding to that. And we know that plants are more vulnerable at certain stages for salinity that we could look at. I find the biochar work very interesting. I've seen Shamin's work, and so that's very nice to see. We saw some interactions between the kind of nutrient salinity treatment and the biochar. I think that's something really interesting to look a little bit further. Because in some experiments we saw some interactions, in other not. If we expect the biochar really to be buffering the salinity, we should actually expect some positive kind of interaction. So that will be nice. So looking at the more broader picture, I think also there's a need of the kind of larger scale future scenario work where we look really at the coastal zone as a whole, what happens with salinity, combine it with the kind of local work that is here, integrating a bit more the different time and spatial scales. We could look at that. That would be very interesting to look at. And we're trying to make a first step of that with ISFAT's work during his PhD, where he's collected a lot of data, but we're now working on really integrating that also into our modeling systems and really see whether we can actually model a bit better the impacts of salinity. And again, then looking whether we can also resemble some of these seasonal cycles. So that will be something And that would also help us maybe a little bit more to advise farmers on how to deal with salinity, on timing of the planting, maybe when do you need to manage the salinity. That could even maybe, when to manage this with biochar applications, etc. So that's where I would leave it for now. Back to you, Katarina. Yeah.
Thank you very much. Thank you for your introduction and very interesting work what you're doing there. Professor Shamim, please come in.
Okay, thank you. Okay, thank you, Catherine, for your for organizing this session. This is Shamim Mia, and I am working as a professor at Portugal Science and Technology University, and I did my bachelor from Bangladesh Agriculture University and MSc from there, and then also received masters from Wageningen University between 2011 and 13, and later I received PhD from the University of Sydney, Australia. And both my master's work and PhD work was on biochar, and you can see that already 2 presentations with biochar. So my main research focus is on biochar, and also the interaction between biochar and soil properties, soil nutrient dynamics, development of biochar based fertilizer, this kind of thing. So let me make some comment on the presented papers today. The first paper was presented by Mr. Isfatuzzaman, and yeah, I was involved with that work, and I really liked his work. And in his presentation, he presented data on seasonal and temporal variability of soil salinity in the coastal belt. And he showed that, there are variabilities between locations and also time. So salinity is higher in the drier period, for example, in the month of April and May. And if you go from inland to the coast, the salinity increases. And in his presentation, he also tried to, integrate satellite-based imagery data to the measurement, and he found good correlation and a regression, I should say. And this is something we need to, explore. So if you could have a good data set from satellite-based imagery, then probably this data can be used for advocating the farmers in managing their crops. Before going to detail, advocation or suggestion to the farmers, I believe we need to, combine or integrate direct measurements of salinity in the soil, and also integrate that data with the satellite imagery for a couple of years, and we need to have a good foundation so that we can advocate farmers with confidence. One of the other important aspects of ISPAT presentation was that finding some solutions or looking at the variability of salinity with crops or without crops. And you probably have noticed that when there is a crop, the salinity is bit low. And also there is differences between land types. The salinity varies with land types. So in the lowlands or medium highlands, the salinity is high. And this is probably due to, easy intrusion of saline water. So this is also need to be studied extensively so that we can, say something about differences or variability in salinity along with the gradient of soil, so that farmer can manage their crops better. Coming to the second presentation and this presentation was made by Mr. Nitu. He is also working in our group, and he presented basically 3 different studies. In the first study, he was trying to understand the soil buffering capacity of different soils. And I believe this is really interesting to me because, if a land receive, a particular level of soil loading, and in the same land, if you have 3 different soils, and then you could expect that the crop growth or crop performance will differ based on the soil types, since the soil buffering capacity of different soil is different. So one of the research or one of the future research could be to understand the soil buffering capacity of the coastal area, so that in future we can map these zones and then advocate the farmer based on the results we have. In the other presentation, the third presentation, and partly in the second presentation too, there were soil organic amendments, and these organic amendments was trying to this organic amendment was used to mitigate soil salinity in both of the cases, and some interesting result we have found. And I think that the organic amendment, as I said, could buffer soil salinity and also increase nutrient availability and increase water availability that could help crop growth. However, I think future research is needed to understand in-depth science, and we also underscore the importance of showing the results to the farmer so that they get interest or they get idea what kind of management they should take in managing their crop. For overall management,
in that regard, sorry to interrupt you, but in that regard, may I ask you a question? Because you are saying, on the one hand, we need more research, and on the other hand, we need to show the results to farmers. Now, I think that in line of climate change, we have no time to waste. So if we wait for the researchers to do more research, then we may be late to discuss it with the farmers. How do you think we can tackle this matter? What do you need at your level to speed up the process?
Well, this is really an interesting question, and what I think for addressing this kind of situation, I believe we could bring the farmers to our research site, or even we could also conduct our studies directly to the farmers field, so that the research result can directly transmit it to the farmers, and then they can manage, or they can get the idea of what they should do, rather than doing research separately in the laboratory and keeping the farmers away. So it should be like in two-way process. That's what I think.
Okay, if you are suggesting that, but you're not doing it at the moment, so I think there is a gap. That's why you are not doing it yet.
This is not exactly
difficult, right?
correct. This is difficult. It's not exactly correct. We have some demonstration each year. So like this year, we have also farmers demonstration of experimental fields. And yeah, we do have some sorts of extension. Not really as you assume that we will invite hundreds of farmers, but we do invite 50 farmers to our research field and show what we are doing. So we do that. And we also train the farmer each year on management aspects.
Okay, no, I certainly believe that you're with good intention there, but in order to make numbers and in order to do it at a larger scale, then there is more needed. I see something coming up from Dr. Bhattacharya in the chat. The research result, cross-visit and linked with the Department of Agriculture Extension can expand the knowledge sharing platform. Thank you very much for that suggestion. I think that's indeed a very good suggestion. And I think that Professor Shamim is also trying from his side, but I think it's also not always easy. There are some impediments to make that work. Am I right?
Yes.
What do you need?
What do I need? Well, first I think I need some money so that I can invite and entertain the farmer, and it's always cost money, and also manpower to do that. So I am a single man, so I need some hands so that they can carry out some of these jobs.
Okay, so you're very interested to work together with farmers, and you would like to have the means to do so. I think that's a very important conclusion also in this regard when we are discussing, because yes, we need facts for informing the farmers properly. However, there are so many variables that is also seen from the presentation that you can kind of do more or less. So you would like to be as close as possible to what the farmers need, so that you will be testing what they require and not in a way what they wouldn't require. Now, at the same time, and then I'm kind of going to Professor Fulco, who mentions the longer term issue. So while on the one hand, there is a need to link to farmers to get immediately applicable knowledge, there is also the need for a kind of longer term information. Because if I am a farmer in the Potuakali area, let's say I have some cattle, now I know that there will be more markets for milk in the future, though I may not know exactly how much, but those cattle, they need food. And I also know that what was shown in the presentations, that in the coastal area, the salinity is increasing. Now, if I have more market for milk, then it's a good investment, right? But if there is more salinity, will there be fodder? I cannot feed my cattle salty water, right? So is it a good investment? So in order to be able to inform farmers about the longer term perspective, we also need that longer term perspective. Is that what you were hinting at, Professor Fulco? Your microphone is off.
Yeah, I think that's a good example. I think for some of the immediate decisions, we also need some longer term outlooks. So I don't think we should bother the farmers what they should do in 20 years. But I think there is some longer term, if you want to set up a real cow farm or milk farm, you need to start from scratch. That can be some significant investments. I think these kind of questions also, it's probably up to more also for the Bangladesh government or other institutions to look where in Bangladesh, if there is an increase in demand for milk, where in Bangladesh could you actually do the cow farming? And yes, then maybe the salt sowing won't be the most promising one to start. So I think I think also there's a number of things we can do to combat salt and the kind of, adaptive kind of coping approaches that farmers can use, maybe changing a bit of the crop types. We can have salinity, salt tolerant rice varieties, maybe a bit of better water management, but maybe in some of these zones, more significant transformation is needed. And that might take some time because we can actually really have that transformation. So I think that's where we need the kind of longer term outlooks that we can also, inform the farmers. Well, you might be able to do certain, farm types within the coming 10, 20 years, but after that, we might need to go for transformations. And of course, those transformations need to be facilitated by the regional work as well. Yeah.
Yeah. No, sorry to interrupt you, but you mentioned the agricultural transformation, and I'm not sure if everybody understands correctly. So when I do adaptation, I am kind of changing what I do to accommodate. But when I do transformation, I kind of go for something totally different, right? So if I have, for instance, rice, and the rice cannot accommodate with the salinity. Well, I first can try, of course, the saline tolerant varieties. But if I cannot manage with that, then it might be I go for something else. For instance, like I mentioned, the cattle. Grass in general has a quite high saline tolerance. So then that might be a good option. So that's what you mean with transformation, right?
Yeah. I mean, that could, that could be even go further that we, stop farming altogether, etc. So that you can even take it a step further than that. So that you say, but at the farm level, the kind of transformation would be really go, from crops to cattle, or the other way around, from cattle to crops, or we could even talk from agriculture to agriculture. Of course, those kind of options are then available. But it's very often that the farmer cannot do the transformation on its own. I mean, if there's no, if he has if there's nobody to buy his milk, if there's nobody to buy his new products, then he cannot do the transformation. So that's often there. A farmer by itself can maybe change his crop types or his planting dates, or even the biochar. That's something the farmer can do, although they might need some supply of biochar. But that's something you can do with the individual. But the transformation often asks a bit more broader action.
Yeah, so for transformation, you need to look from the production all the way to the marketing and the consumption of the crops. Yeah. So then in a way, you would go more for a kind of agriculture and food system type of analysis in order to bring all of that in the picture. Professor Shamim, do you already see that kind of transformation is going on in what farmers are doing at the local level? Are farmers changing?
Well, I think a little bit, not at larger scale. So farmers are still trying to adopt with their existing crops and livestock, but I think they are not changing or shifting from their crops to livestock or livestock to fisheries. There could be some this transformation is happening probably in some areas. For example, in extreme saline condition in the Biochar region, where they move from rice cultivation to shrimp cultivation. So that could be in some range.
And do farmers move from cropping to leaving the land fallow?
Yeah, of course. In some areas, farmers leave their land fallow due to high salinity, and you already have seen that in ISPAT presentation. There are large land. When I visited with CIMIT 2 or 3 days ago in the coastal area of Bangladesh, and I have also seen a lot of land being fallow due to high salinity, especially in the some part of Patuakhali and Bangladesh. Yes, you're right.
And in the presentation, it was mentioned that if the land is fallow, then salinity may even be more than when there is a crop on the land. Yes. So that actually makes the situation worse.
Yes.
So because it's bad, farmers leave the land, but because they leave the land, the situation is getting worse.
Yes.
We need some innovative research to tackle that matter, right?
Yeah.
Any suggestions?
So what I was just thinking, for overall management of the coastal area, I think we need some novel technologies so that farmers can grow or continue their agricultural activities in the area, even at extreme salinity. For instance, farmers can adopt reverse osmosis technique, or farmers can cultivate crops, especially vegetables without any soil media, without any contact of the saline soil, in bags, or even in the field, maybe making bags and putting all the nutrients and water in a poly bag or something like that, and use the surfaces to harvest solar radiation, some sorts of hydroponic system or something like that. So for that we need research. And the second point I would like to mention is that salinity can be predicted. Yeah. So when salinity is coming, it is important information for the farmer, and when it's coming. So in last year, what we have experienced that suddenly we had a flash flood with very high level of salinity. It causes total crop loss in some part, and there was a huge outbreak of diarrhea in the coastal belt. So I think we need to do something on that point. So if we have some model, or if we have something to simulate considering the upstream flow and also this salinity around along the coast, if we could predict the salinity, and also in relation to the moon to have high tide, then we could provide this information to the farmer, and then manage the health of the people and also the crop data. So we need research and some sorts of investment on that particular issue. And my final comments is that, we need to bring people together, to bring the stakeholder together so that we could handle this situation better. And I believe we are here to bring or make some sort of consortia so that we could act on this issue. So that was all from me. Thank you. That's all. Yeah.
Okay, thank you very much for your comments. Vilko, did you want to add something to the earlier comments that you made?
I think giving the farmers better information and also predicting better the salinity, I think is a really good suggestion. And we've also discussed that when we were in Bangladesh last week to also add to our kind of information services that we are developing, to also have a bit of a salinity component to that. I think that's in addition, I think there's a need to train the farmers how they can use this information. That I think is also an important, and that links also to that seasonality, and maybe about the variability that you have from year to year. And it's also something to look at. And maybe if we can predict the salinity a bit more, even give them more information. We discussed with some farmers, do you wait for the rain, or do you actually irrigate with some saline or slightly saline water? And that's also something I think where we could help farmers with better information and better training. Yeah, that's it from me.
Okay, thank you very much. I'm seeing in the chat from Dr. Bhattacharya about the reduced upstream flow and the change of the raining pattern. Also, that increases the salinity. That's absolutely right. And that in combination with what Professor Shamim also mentioned, that if the land is fallow, that there is more salinity coming into the fields. That has to do with the capillary rise of the soil. So there are different mechanisms in play, and we need to get these different mechanisms in the picture, while it is very highly temporal different as well as spatially different. So that doesn't make it easy to get it into the picture. But that is also a kind of research part of the story. What you also said, both of you, is the kind of link to the users of that knowledge. If we want the knowledge to be used, then we also need to be close to the different stakeholders. And in some cases, these are the farmers, as was mentioned, but also in some cases, these are the policymakers, because they are the ones who are making the programs to support the farmers, or to create facilities that are supporting the farmers. Okay, thank you very much. In conclusion of this session, I like to kind of summarize a bit what we have as lessons learned. I think we feel the need that to kind of work with farmers to provide them relevant information. In order to do that, we need to collect data locally and make it useful for farmers, and giving them the opportunity to use it. So kind of training, doing the research together, so that they know what we are talking about, and that the farmers also can tell us what they are coming across, so that we can use that information. The second, so collecting data locally is kind of crucial. The second lesson learned is about the systematic manner we need to address it, and then not only focusing on the production, but on the total situation, where we think about the salinity as improving the crops, adjusting the cultivation or the water management. We need a kind of systematic analysis, and the food system analysis can provide a good entry point in this regard. The third lesson learned is that the upscaling part, that this is a matter at field level, but also a matter of regional level. And how do solutions at the field level work out in the regional level and vice versa? We need to look into that. And if I may, a fourth lesson would then be that sometimes the adaptation is not sufficient, and then the transformation is something that may be necessary, and that brings the kind of longer term aspect in. And we need to be able to give farmers information about that, as well as that we want to work with them together so that they can create their own futures. Okay, thank you very much, all of you as the speakers. Thank you very much also to the ICA team for the backup in the session. And in particular, I want to thank Madiha in this regard. Thank you also, Sonia, for backup and assisting with the reporting. Thanks also to the speakers who gave interesting presentations, for the people who provided support and opportunity to give answers to the question in the chat. We will follow up with you as well after this session. And thank you very much, all in the audience. We look forward to be in touch with you, and because this is definitely a kind of burning issue in which more needs to be done for local level adaptation. Thank you all very much.